How to read and write science in English. Science, middle school, first grade. Science, the living organism. What's life? Characteristics of life. It's not easy to give a precise definition of the term life. Living organisms are open systems, continually receiving and disposing both energy and materials. If it stops or breaks down, the organism dies. However, by observation and experiment, we can record the activities that are characteristic of organisms as follows. Nutrition. All living things have to feed in order to gain energy and material needed to make the living matter protoplasm of their body. This process is called nutrition. Respiration. This is the release of energy by the breakdown of food substance like glucose in all living cells. Excretion. There are numerous chemical reactions occurring in the cells of the organism. These are metabolic reactions. Some of these reactions produce substances which are useless to the organism or may even be harmful. The process by which the organism removes such metabolic waste substance is called excretion. Growth. Growth is a permanent increase in the mass and volume of an organism. Some of the newly formed materials are used to repair worn-out parts of the cell. The rest is added to the organism living matter to bring about an increase in size. This may make the organism more complex or even change its form. This kind of growth is characteristic of most living organisms. Movement. Movement is a characteristic of organism. It's more easily detected in most organisms than in plants. Most plants are unable to carry out locomotion, but slow movement of their body parts are always take place. Example, the flowers of plants slowly open and shoots bend toward the right as they grow. Sensitivity. Animals and plants are sensitive to any change in the surrounding. They often react to this change in a way beneficial to themselves. Such a change or external influence is called stimulus, plural stimuli. The reaction of an organism to stimulus is known as a response. Reproduction. All living organism is able to reproduce their own kind. In this way, the species live on though individuals die. Thus, reproduction is necessary for the species to survive. Adaptability. Living organisms are able to adjust and adapt themselves to change in their environment. This adaptability increases their chance of survival and the perpetuation of their own species. For instance, to get enough sunlight, a plant may grow very straight and tall to above the plants around. Distinguishing of living organism for non-living matter. Some of the characteristics of living organisms given above can be found in certain non-living things. For example, a motor car can move and give off waste product when its fuel is burnt. It's also a well-organized and complex structure. Indeed, men have often used machines as a model to help them understanding how living organisms work. But machines do not reproduce themselves and do not grow. Thus, all these characteristics must be considered in distinguishing a living organism from non-living matter. Cells, the basic block of life, the building block of life. The majority of animals and plants are made up of millions of tiny cells, just as a house is built of bricks. The term cell was first introduced by Robert Hooke in 1667 after he had examined thin slices of cork using one of the earliest microscopes. He saw that the cork consists of closely packed little boxes with thick walls which appear to be empty. The boxes looked to honeycomb and he called them cells. However, it took many years of study and experiment for any clear idea of their real nature. What Foucault saw was only the dead cell walls. Today, our idea of the cell of a cell is quite different because you can study the living cell with more refined techniques. Cells are the basic block of life, the simplest unit that can live independently. Inside the cell, thousands of chemical reactions occur every second. Each these reactions which keep the bodies of animals and plants working. All of these reactions from the metabolism of the cell. The cell is literally a chemical factory. It brings in raw materials such as organic molecules like sugar and inorganic salts. It uses these raw materials to make new molecules such as protein, which the cell can either use itself or send elsewhere in the body. Microscope. There are large cells big enough to observe with the naked eye. The best example are the egg cells of some animals, such as a hen or a frog. However, most parts of a cell are too small to observe with the naked eye. Therefore, we have to use tools called microscope to observe them. Microscopes can largely be divided into three classes: optical microscope, electron microscope, and scanning probe microscopes. Optical microscope functions through the optical theory of lens. Optical microscopes magnify the image produced by the passage of light through the sample. Optical microscopes, through the use of the visible wavelengths of light, are the simplest and hence are the most widely used out of the three. Optical microscopes use refractive lenses, typically made of glass and occasionally of plastic, to focus light into the idea. Typically, a light microscope magnifies objects up to 1500 times. Ocular lens, eyepiece, revolving nosepiece, objectives, stage clips, diagram, light source, coarse adjustment knob, fine adjustment knob, optical microscope. Looking at cell, animal cell. Use the blunt end of the clean toothpick to gently scrape the inside of your cheek. Place the scraping in a drop of iodine solution in a clean microscope slide. Carefully lower the cover glass at an angle to prevent air bubble over the material on the slide. Examine your preparation under the microscope. Locate the cell with the lower power, then use the higher power to examine some of the cells. Draw one cheek cell. Label it as fully as you can. Looking at cells, plant cell. Obtain a flash scale leaf from an onion bulb. Cut off a small piece of epidermis skin. Place it on a microscope slide. Add a drop of iodine solution and cover it with a cover glass. Examine the epidermis under the microscope. Draw and label one epidermis cell.